Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So many apps that you'll want to build will involve more than just one page. Up to now, the simple examples we've been creating involve just the main page.xaml. But what if we wanted to navigate to a second page? Let's call it page2.xaml. How would we do that? We'll talk about that in this lesson. Furthermore, perhaps the user selects an option on main page.xaml, and based on that selection, we want to navigate to page 2 and pass along certain information that will change what happens on page 2. So how do we pass information from the main page.xaml to page2.xaml? We'll talk about that in this lesson. Furthermore, suppose that you have a dozen pages in your app and there's various branching from one page to the next based on which option the user selected on any given page, maybe like a wizard style app. So how can you manipulate the history of the pages that have been visited so that when the user clicks the physical back button on the phone, that we can change from going to the previous page back to the first page, the main page.xaml, perhaps. We'll talk about how to manipulate the history of the pages that have been visited, and also how to manually take control of going back and going forward in that history of pages that have been visited. Okay, so to begin, let's create and start with a very simple example. We'll call this just navigation example. And the first thing that I want to do is add a second page. So I'm going to go right click on the project and select add new item. And we could choose this basic page, which has a simple layout of the app's name and the page title at the top, and then we can fill in our details or other XAML here in the body. But for our purposes, the blank page will work just fine. You can see there's actually several different options with pages, and I would invite you to learn more about those and use them as you will, as you have time. So we're going to create page2.xaml and click add. And while I'm here on page 2, what I want to do is add some XAML to this page. So I'm going to remove the grid and I'm going to paste in this stack panel with a margin, text block. I'm setting the text to page2.xaml so we know which page we're currently on. And then these last two items we'll use a little bit later. For example, whenever we're passing data from main page to page 2. And then we may even navigate to a third page just to demonstrate some other features of navigation. While I'm here, I'm going to also go to and right click on the button click event here and select go to definition so that it creates this method stub for us. We'll need that whenever we attempt to compile our page 2. Okay, so now let's go back to our main page.xaml, and here I'm going to paste in some XAML, getting rid of the grid and instead replacing it with a stack panel. We have a text block just to let us know what current page we're currently on, main page.xaml, and then also a button with the text go to page 2. The idea is that the user will click this and will load up page 2 into the viewable frame of our app. So let me right click on the button click event handler here so that we can go to the definition. It'll create the method stub, and this is the code that will actually perform the navigation. I'll just paste it in here. So there is some ideas that we'll talk about in an upcoming lesson regarding the life cycle of the app, what happens when the application first starts. A lot of that will be from this app.xaml.cs file, which we'll talk about later. But in a nutshell, when your application launches, it has access to the phone's window. And we will immediately create a frame object which represents the window to our app. That frame object will be what we load page objects, the page class or instances of the page class, like for example, our main page.xaml. If we were to take a look at the class declaration, you can see that, where am I here? Whoops, there we go, main page.xaml. .cs. All right, you can see that this main page class is an instance of page. So the frame will allow us to load and unload page objects in and out of the frame. So the frame manages page objects and what's currently displayed in the window. Furthermore, it's what keeps a history of all of the pages that have been navigated to, and will allow us to navigate back to those pages. It'll also allow us to an opportunity to save the state of those pages before they're unloaded from memory and more. Okay, but at any rate, I think we have everything we need now to run our app. So let's go ahead and run it. And we'll need to talk about that navigate method in just a little bit more detail here. Forgot to do that. Let's go ahead and click on the go to page 2, and you can see now we're on page 2.xaml, and we could click page 3, but it won't do anything just yet. All right, let's take a look at, and I got sidetracked a little bit here, main page.xaml, the button click event. So we're working with the frame object. The frame represents the window that's currently visible in our app. We're calling the navigate method, and there's a couple of overloaded versions of navigate. We'll talk about that in a moment. But at a minimum, navigate will create a new instance of a page object. Which page? Whatever the pages that we send in here. So we want to get the name, the type name of the page that we want to work with. In this case, we're using the built-in method type of to retrieve the current type of our page 2 class and use that to navigate to it. All right, so now let's do something a little more interesting and pass along some information from one page to the next. So in our button click, I want to use frame.navigate, but this time in addition to passing in the type of page 2, I'm going to pass in a simple string. We can pass anything as a parameter from one page to the next. This is of type object, so it'll be boxed up into an object and then unboxed out on our page 2. So this is how we send the a parameter from one page to the next. How do we retrieve it and work with it on page 2? Well, there's one method in particular here, this onNavigated2 method, that has an input parameter of navigation event args. And the navigation event args has a parameter property that allows us to get to whatever was sent from the previous page. And it has some other properties as well that allow us to determine which page was the one that we navigated from to this page, and so on. All right, so what we'll do in the onNavigated2 event is we'll set the text block text property that we added whenever we copied our XAML onto this page2.xaml. We will set its text property equal to the parameter. Now the parameter again is of type object, so we'll want to call toString in order to get it into the right type and display it correctly on screen. So let's go ahead and run the app. And this time, whenever we click the button to navigate to page 2, now we get a nice big message, hola, from the main page. Great. All right, so in addition to this onNavigated2 method, there's also an onNavigated_from event that we can handle that will be triggered right before the current page is removed from the frame as the new page is loaded into the frame. So this might be a good opportunity on the onNavigated_from to clean up any resource or save the current state of the page depending on whatever your application needs. Okay, so typically sending a simple data type from one page to the next is not enough. This doesn't really help us a lot. What we may want to send at a minimum is like the ID of a given item that was selected so that we can see more details about that item on page 2. Or perhaps we need to send multiple pieces of information. We might need to send, disparate pieces of information from one page to the next as we maintain state across all the pages for our needs. And so in that case, what we may want to do is create a custom class that will contain all of the things that we want to pass from one page to the next. And so this is typically called a navigation context object. And that's just a convention. It's just something we're going to build. It's not something built into the framework. It's just a pattern that I see emerging as apps are built and they're passing data from one page to the next. So we're going to add a new class. I'm going to call this navigation context .cs, and here what I'll do is just create a class. I'll replace this stub with a couple of public properties like ID, name, description. Okay, you might need to do more than just this, but the idea here is that since you're passing a parameter of type object from page to page, you can pass anything you want to pass. You can pass a collection from page to page. In this case, we're just going to keep it simple with an instance of this navigation context object, and we'll fill in some properties. So let's go ahead and do that in the main page.cs. Let's go ahead and comment that line of code out, and we'll do something a little more elaborate here. So we'll create a new instance of that navigation context object and populate its properties with dummy data, so ID, name, and description, and then we'll call the navigate method of the frame, passing in the type of the page that we want to navigate to, and then an instance of this navigation context object. So that's how we pass the data. How do we retrieve it on page 2? We're going to comment out this line of code and instead replace it with this line of code, or these two lines of code. So here we're going to still work with the navigation event args e, still work with its parameter property, but this time we're going to cast it to an instance of this navigation context class that I created. Now that we have it, we can work with any of the properties, the ID, the name, or in this case, the description, which will print into the text block on page 2. Let's see it running. And so we see the description from our navigation context instance. This is a test. All right. Again, not very glamorous, but think about the power of what we've just demonstrated here. You can create any kind of type. It can be an instance of, for example, a collection of an individual type that's created specifically for the purpose of transferring data from one page to the next, this navigation context, or simple types, ints, strings, dates, whatever the case might be, from one page to the next to maintain the state across all the pages in your apps. All right, great. So now let's talk about navigation history and manipulating it. So I'm going to add one more page called, it's a blank page called page 3, so that we can navigate to that and then manipulate the navigation, so the navigation history. And so here I am, kind of the same pattern. I'm going to add a text block with just the name of the page, page 3. I have a text block here where I'll display something, and I'll talk about that in a moment. And then a button where I'm going to implement the go back method of the frame. This will do the same thing as clicking the back button here on the face of the phone. More about that in a moment. Okay, so on our main page, on page 3.xaml.cs, we're going to do the following. I want to take a look at all of the pages that we've navigated to up until we navigated to this page. So to do that, what we'll do is work with the frames backstack, which is simply, as I hover over, it's a list of page stack entries, and page stack entries represent each of the pages that we've navigated to, as well as their state as we navigated to them and from them. Okay, and so what we're simply doing here is retrieving a property of page stack entry, the source page types. That will either be like the main page class or the page 2 class or what have you, and we'll just add toString, and then we'll add each of these on a separate line. So that's what the \n character is. And then we'll just print that into our pages text block.text. Finally, what we'll do is remove the last item in the backstack. So if the last item is page 2, since we haven't completely navigated to page 3, it won't be in this backstack just yet. But what we'll do is remove the last page of our backstack. So we're going to get the backstack depth, how many items are in the backstack, and subtract 1 from it to remove that. Since it's 0 based like an array, we're going to remove that last item from the backstack. And the reason we're doing this is to implement this button click event. So I'm going to go ahead and create the stub for the button click. And here what we'll do is simply call frame.goback. All right, there's also a frame.goforward as well. And you can see that there are also several methods that we can call to say, can we go back? Can we go forward? And so on. And that will let us know if the backstack has any items in it, whether to go back or go forward. And we could potentially disable items on our user interface based on that. So we could disable this go back button, for example, if we cannot, in fact, go back. I'm not going to demonstrate that here. Let's go ahead. I think we have enough here to demonstrate this now. Let's run the app. Oh, we need to do one more thing. I forgot. Let's go to page2.xaml.cs. Yes. And we need to actually navigate to page 3, like so. Right, using that simple navigation cell. We should be ready to go now. All right, so from main page.xaml to page2.xaml to page 3. Now you can see I've printed out the backstack. What was in the backstack was, first of all, main page and then page 2. Now remember, I also removed the last item in the backstack, this page 2. So when I click go back, it will call the frame.goback method, and that will take us all the way back to main page.xaml. All right? All right, so that's all I wanted to demonstrate, how simple it is to navigate from one page to the next and how to manipulate the navigation history, the backstack of the frame. Also, you should understand now what the frame does, how to pass data from one page to the next, and so on. And so we're going to use this knowledge as we build more complex applications here in the next few lessons, and we'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, we want to talk about the package.appxmanifest file that we've seen sitting here in the Solution Explorer, but we've never dared open it up or make any changes to it just yet. What I want to do is talk about it at a high level. For example, it contains metadata about your application. In other words, it describes your app to the operating system, including the friendly name of the app, any icons and images that will be used on the start page, what the phone's hardware must support in order for your app to work on that phone, and so on. So I just want to take a quick tour of this package.appxmanifest file. Admittedly, this will lack the context that is probably really necessary in order to understand how each of these values play into the larger picture of building an app. However, and why you might want to use some of these settings during the course of the life cycle of the app's construction. But if nothing else, this will give you some insight into what's possible whenever you're building apps for the Windows Phone. Even if I don't demonstrate those specifics on how to implement a given feature, at least you'll know, oh yeah, I think I remembered that there was something about that in the AppX manifest. That's why it doesn't do this. Or if you're reading a tutorial, at least you'll know what to expect whenever they tell you to go into the package AppX manifest and do blah. Okay. So first of all, as you can see, this file sits here in your Solution Explorer. It's actually used during the compilation process as it compiles your source code into a series of assemblies and then packages all up into a deployment file. So the install package, the deployment file, will have the file extension appx, and so that that manifest file, the AppX manifest, introduces, as I said earlier, introduces the phone to your app. Which assemblies are contained in the AppX file? Which asset file should be used for the start and the app screen to allow the user to click on them and open up your app? What's the app's name? What are the features that the phone uses, and so on. So this is why it's sometimes referred to as metadata, as I referred to it at the very outset of this series of lessons. So whenever you open it up in the main area, I'll just double click it here, and you can see that there's this friendly tabbed designer that allows you to change the various parts of the app, and we'll come back to this view in just a moment. But for now, what I want to do is shut that down. I want to right click on this and select Open With, and I'm going to choose the XML text editor and click OK. And I want to make sure, first of all, to emphasize that you do not want to make any changes here. If you corrupt this file somehow, that designer is not going to pop back up nicely for you, and that's ultimately where you need to be working in. However, as you can see, the package.appxmanifest file is simply an XML file that contains the various settings, and then that friendly designer that we first opened up merely allows you to make changes to those settings in a more friendly way, rather than going to have to dig in through the XML, potentially making spelling mistakes that would prevent the app from being compiled, and so on. So at any rate, you're going to see essentially the file in its naked form. I'd recommend that you don't change this file, at least not until you have a very specific reason to do so. So let's close this tab, and if you're asked to save any changes, make sure you say no, don't save any changes. So now let's reopen the package.appxmanifest file property designer, and what I want to do is briefly review the purpose of each of the settings in each of the tabs, at least at a high level. Frankly, most of the settings are self-explanatory, and yet the nuanced reasons why you might choose to change each of these settings could require more time than I have in this lesson or even a series of lessons. My goal here, again, is just to do a quick review to call your attention to the fact that all these settings exist and where you would change them. And so if you're following some other tutorial in the future, you'll have some idea of where to look for some of these settings. As you can see, there are, 7 different tabs: Application, Visual Assets, Requirements, Capabilities, Declarations, Content URIs, and Packaging. And so we'll start with this Application tab. I would classify this as a catch-all for the properties that don't fit nicely into the other tabs. Many of the settings are utilized by the operating system, such as the display name and the default language and things of that nature. Also, the supported rotations of the app, whether or not your app will allow the user to rotate the phone, and it should change and respond to that change in orientation, or if you don't want to allow that. Also, it will allow you to set whether or not allow storage to SD cards. You might want to prevent users from doing this to prevent them from taking that SD card out of one phone, putting it in another phone, and then copying that app off or using it on a different phone. A way of copy protection, I guess you could say. Below that, you have the notification section. This will allow you to tell the operating system whether you intend to use toasts and lock screen notifications in your app. So a toast displays at the very top of the screen to notify users of an event, such as a news or weather alert, like you see the photo here. A toast notification displays for about 10 seconds unless the user dismisses it with a flick to the right. If the user taps the toast, by default your app's start screen launches, or you can choose to specify which screen of your app will launch. A lock screen notification, as you can see here on this slide, allows you to update the lock screen with text images or numbers that are usually indicating that there's a number of updated items that the user should be aware of. So your users can choose to customize this area with any eligible third-party apps that they choose. So as a developer, you can design your app to be an app that the phone can choose to customize the lock screen notifications area. So the lock screen's app icon, the count, and text are pulled directly from the app's default tile. The info appears on the lock screen only if the default tile contains this info. For example, a count will appear on the lock screen only if a tile displays a count of items that need to be addressed or looked at, or new items and things of that nature. Okay, so that is, in a nutshell, basically the catch-all for the entire application. Next up is the app's visual assets. And we're going to use this a little bit later for when we build a real app to change the tiles, the splash screen, and more. Notice that there are different sizes that are required for different states of the tile, whether on the start page or the apps page on the phone. So on the start page, the user can decide whether the app should be small, medium, or large. So you need to provide different assets for those three different sizes. The next tab, the Requirements tab, is for hardware requirements. For example, if you were building an app that needed the NFC capability, you would click this Requirements option and you would tell the phone that in order for this to work correctly, my app to work correctly, it needs that requirement on the phone, that capability of the phone to be present. So the next tab is the Capabilities tab. A capability is a request for permission. So suppose that your app needs or it wants to access a given feature of the phone or the data on a given phone. You can't just, as a developer, go grab that capability or that asset. You need to ask permission of the user of the phone because it's usually handling some potentially private information that the user may not want to share with just any app, like the user's current location or any of its contacts. I don't want just any app knowing who my friends are, okay? So I may deny the app that capability. The next tab is Declarations. So think of declarations as other ways that the phone's operating system can execute or can enable certain features of your application. So for example, we might want to allow our application to execute a background task every half hour or so, and that background task will change the phone's lock screen image. So in that scenario, we would add a background task declaration and configure the timer, the executable that we want to be run, the entry point into that executable, and so on, to launch that part of your app that changes the image on the lock screen every half hour. Okay, or in the case of the, let's remove that and go up to, or try to remove it. All right, there we go. Let's go back to the top here and go to the File Open Picker and add that one. And in this particular case, we might want to allow other apps to use our app to choose a given file type that's managed by our app. When somebody goes to open a file, maybe it's a file that belongs to our app, and we want to allow a different visualization for the selection of that template, we're telling the operating system, the phone operating system, to whenever a file open operation happens, include us in the mix. Okay. All right. So let me go ahead and remove that and move on to the next tab, which is Content URIs. The idea behind this is actually pretty cool. In a few lessons, we're going to learn about the web view control. So it can open up and display web pages. We'll be using it to display web pages that are hosted locally in the app's project. However, you can also open up external websites as well. Now, if that external website happens to be running JavaScript that executes a command called window.external.notify, then that external website can pass data into your phone app. And so the trick is that you have to indicate right here which URIs that you want to allow to pass information into your app. Right here on this page, you would put in the URIs that you want to accept data from. And then it has to also be one with an SSL certificate, just a requirement. So on your side, then, as a developer of the phone app, you would handle the WebView_script_notify event and retrieve the data that's being sent. And then finally is the packaging tab. And as the instructions say at the very top of this tab, they deal with the information about packaging the app for deployment. The package name is a globally unique identifier, or a GUID, that differentiates this app from all other apps that were ever created by the phone, no matter which user, at least ideally, as well as the display name, the version, the current version of the app that you're publishing. As you make bug fixes and stuff, you'd want to come in here and increase the build number, the minor version, and potentially the major version of the app. Okay, and also other things like the publisher display name that you want to be seen in the store and things of that nature. Okay, the last setting, this generate app bundle, allows you to split up your app into multiple parts so that it takes up less space and requires less time to download for the end user. So you might choose to do this if you're targeting multiple languages and you have image assets that target different screen sizes. And so you would split up your app appropriately into a series of packages that segment those resources. So in these cases, the end user would only download the package that applies to their language and their screen size, and not all of them that you've made available, like a German large screen versus the Spanish version of your app small screen. Okay. All right, so in a nutshell, that's all the settings that you can make in the package.appxmanifest file. At the outset, I said that the value of this lesson is calling to your attention the fact that these settings actually exist and how you'd go about changing them if you ever needed a given feature. Furthermore, it helps you see what's possible. The features that you may want to employ in your app, even if we don't demonstrate them in this series of lessons, at least you know the kinds of things that your app is capable of, and you can go and research more about those through MSDN articles and so on. Okay, so we're at the point now where we're confident enough we can build our first real app. In the next lesson, we're going to build a simple app, but it's going to employ a lot of the ideas that we've been building on up until now, so that's pretty exciting, and we'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. All right, so we're going to build our first complete app. We'll build several of these throughout the course of the series. And I'm not going to waste a lot of time. I've already created this app once as a little reference point for me. So I may do some copying and pasting of code as I've done just to make the progress quicker. I want to emphasize, however, that you should pause the video and take the time to type in the code. It helps build muscle memory. It helps you become more familiar with the environment. You'll gain insights and epiphanies as you're writing the code out yourself. To save time, however, I'm just going to paste in a lot of the code and then talk about what each of the pieces are and why I added them. You should pause the video at those moments and type those things in yourself that I paste in. All right? So let's go and get started. I'm going to create a new project, and we'll call this Tip Calculator, and it will help solve calculator. Okay, it'll help solve one of the fundamental problems that I have whenever I'm out and to a restaurant and I'm trying to figure out how much to tip the waitress based on the service. And usually I'm a pretty generous tipper. However, for the sake of this app that we're going to build, we're going to give 3 options to help calculate either 15% for mediocre service, 18% for average service, good service, and then 20% for exceptional service. And you can expand this out for any type of simple calculation. So let's go ahead and get our environment in place here. 50%, we'll move this over. And instead of dragging and dropping, like I said, the controls, I'm just going to paste in and then maybe type some things in as we go. So let's begin by laying out the user interface. And what I want to begin with is some rows. And I'm going to create 3 rows, a 50 height row, a 100 height row, and then a star row, which will take up the remainder of the space. And this is where we'll add most of our the remainder of our controls. So this first row will have just a text block that will have the name of the app in it. So we'll do something like this, tip calculator. We could actually move that into row 0. And then we might add a second text block to say enter the bill amount or something like that. And that should be in larger font. We'll put that, let's see. And I'll move this around a little bit so that you can see it. Font size equals, let's go 36, something along those lines. Maybe even 48. It should like bleed off the side a little bit. That'll probably be good. All right. So let me format my XAML here to make things look good. Great. All right. So the next thing that I'm going to want to add is a stack panel, because everything else inside of this third row, I want it to be inside of a stack panel, so it'll just be flowing from top to bottom, okay? And I'm going to add a text block and a text box, like so. And so you can see I'm going to have this paradigm where I have the name of the field above it in a smaller text block, and then whatever it is that I want to work with, like a text box in this particular instance, below it. And you can see that I'm presetting its value to $0.00. I'm setting the text alignment to the right, so that means I want the text to be aligned to the right, like a dollar amount usually goes from right to left. We are also using text wrapping equals wrap. I could probably get rid of that. The input scope is a number. That's important because I want people to be able to type in numerical amounts, not have to type in like, you know, or see the QWERTY keyboard. And so then the only other thing that really matters here is the various events that I'll be handling at some point. So you can see that whenever the text changes, I may want to handle that event. Whenever the text box loses focus or whenever it gets focus, I want things to happen. For example, when the text box gets focus, I want all the text to clear out because I'm going to type in a new value. I don't want to have to use the back button or whatever the case to clear out the value. So when it gets focus, clear it out. When it loses focus, I want to format whatever number that they typed in with a $sign, make sure that it's valid, and may even recalculate the remainder of the values based on what I type into the bill amount. Okay. Whenever the text changes as well, I might change the calculation as well. Okay. So I'll come back to those in just a little bit. Let me add the next settings here, which will be the text block that says the percentage to tip, and then the 3 radio buttons, either 10% for horrible service, 18% for acceptable service, or 25% for great service. Okay, I forgot what the values were that I was going to use. Notice that I've given them a group name, so they're all part of the same group. I didn't have to do that, but I decided to here. Also, on the radio button click, notice that they're all calling the same method radio button underscore click, and whenever that changes, I'll want the final calculations to change as well. So there will be several different things triggering the change of the calculated amount, the final amount of tip and total bill amount, which we'll add here in just a moment. Also notice that I'm using this tag property, and the tag property is a holdover from many, many, many years ago. And basically you can put in this tag property anything you want to. What I've used it for in this particular case is the actual percentage amount that will be used for the calculation. So instead of having to do some switch to see what the content was and compare it and then give it a numeric value that's associated with that particular content. Instead, I'm just going to put the actual percentage inside of the tag so that when a radio button is selected, I can just look at its tag, convert it to a decimal, and then use that in my calculation for the percentage tipped. Okay? So 0.1 for 10%, 0.18 for 18%, 0.25 for 25%. All right? All right, so moving on, I'm going to add now the amount to tip, and this will just be two text blocks. One will be for the label, and the other will be for displaying the amount that will be tipped. So we'll take, if you type in $100 and you give them a 10% tip, what we would expect to see here is a $10 tip, okay? And we'll have to work on that calculation a bit. And the final part of our layout here will be the total amount. So you'll take the original bill amount plus the amount to tip, and that should be a total bill amount. So here again, if the total bill or the bill amount was $100 and you say I'm going to tip them $10 for horrible service, the tip amount would be $10 and the total bill would be $110, right? Okay. So now let's move on from there. And what we'll want to do is start, let's create these stubs for each of these event handler methods, and I'm just right clicking on them and selecting go to definition. I could also select one and hit F12 to accomplish the same thing if you are a shortcut guy. I think that's all that we have to worry about there. All right. Now I could go about this in many different ways. I could just create all of the code right here in my main page XAML.cs, but I have larger aspirations for this app. Sure, some people might be using it on their phone, but some people might have their Microsoft Surface or other tablet, Windows 8 tablet, with them while they're out to eat, and they may want to use the app in that context instead. So I have designs on a future video, in fact the very next video, where we'll create a universal app to build both the phone version of the app and a Windows Store version of the app for use on Windows, tablets, or on desktop. So in that case, I'm going to add another file called, add a class that we're going to call tip. And this will make it easier for me in the future, keeping all of my all the important stuff like the calculations and the data members isolated into their own class. So we'll start by creating some public properties. Whoops, prop, tab, string, bill amount. Now you might be wondering, why am I using strings instead of like double or decimal? And the reason is because I want to format these and make them publicly available so I can more easily associate the values and not have to do the conversion of the values inside of the main page.xaml.cs. So I want to just reference what the bill amount property is and automatically assign it. By keeping that formatting inside of my tip calculator or my tip class, it will make it more easily reusable for the universal app for Windows 8 or for my phone. Okay, so that's the thought process. That's why I'm making things strings. Okay, and so we'll create constructor, and inside of this constructor, I'm going to go ahead and initialize each of these to string.empty, and that's a good practice to get into to initialize everything here. All right, next up, what I want to do is create a single method that will actually do the tip calculation. So I'm going to go public void calculate tip, and what I'll do is allow the user to pass in, the user of this class to pass in the original amount, and then also I'm going to let them pass in the percentage, the tip percentage, and we'll use the tag property for that. All right, so I'm going to need some local variables to do this calculation. So I need like the bill amount, and these are just the numeric equivalents of the strings that we're making publicly accessible through our auto-implemented properties here. Tip amount. But these will be actually used for the calculations before we format them for display. Okay. So what we need to do here is I need to check. I need to take a look at this original amount, and I need to parse that into a double so that I can, do the multiplication against my the tip amount and percentages and things of that nature. Right. So we'll do double.try parse, and we'll pass in the original amount, and I'll go ahead and get rid of the $, and I'll just get rid of that completely. All right, and then as an out, I want it to put that into the bill amount, like so. So if double.try parse, if that succeeds, then I should have at that point, oops, that's going to be an out parameter, right? Okay, it likes that. Why doesn't it like this? Empty literal character. Can I do that instead? Okay, I like that better. All right, so now that I have the bill amount populated, I can do this. I can calculate the tip amount. So that will be the bill amount times the tip percentage. And then the total amount will equal the bill amount plus the tip amount. Right? And then finally what I want to do is actually assign values to my three public properties. So this dot bill amount equals string dot format, and I'm going to use that currency formatting character, so 0:C bill amount. That should work. This dot tip amount equals string dot format 0:C and tip amount. Cool. And then this dot total amount equals string dot format, and the same thing again, 0:C total amount. Great. All right. All right, so that's pretty easy. I'll just call calculate tip, and then I should be able to count on the fact that these values will be populated then. Now, I have to admit, I probably wouldn't take that strategy. Typically, I don't like to rely on the execution of a method prior to values being set in public properties, but for this simple app, this will work just fine. I would probably want to have a whole other class that implemented this calculation and then return back an object of type tip with these values filled out. But again, I'm just keeping this nice and simple for now. Back in my main page.xaml is where we'll finish my work up here. And what I want to do is want to create an instance of tip because we're going to need that. So tip. And then in the constructor of this page, so tip equals new tip, like so. Oops. All right, and now what I'm going to do is actually, because all these will need pretty much the same calculation to be performed, I'm going to create a private void perform calculation. And so first of all, what I want to do is get the selected radio button. So to figure out how much, or to get that, that tag value that I can send to my calculate tip method on my tip object. Okay, so let's go var selected radio equals my stack panel dot children dot of type radio button, and we're going to find first or default where r dot is checked equals true. So we'll find the radio button in the children of the stack panel. We'll find the first one that's been checked. All right, so that's a little bit of link code that can allow me to search through all the radio buttons to find the selected one. That's a marked improvement over what we saw when we looked at the controls a couple of lessons ago. Each of the individual, we did an if and looked at the name of each radio button to see if it was selected. This is much more clean and convenient. Okay, now that we have the radio button that was selected, we can then call tip.calculate_tip, and I can pass in the bill amount textbox.text, which should be a string, and then I'm going to call double.parse, and I'm going to send in the selected radio.tag property and since that tag property is, I think, just an object, I'll toString it. So I'm going to do a conversion to string, then a conversion to double, and that's only because the it just is the way that it really has to work. Okay, I'm just going to set a parentheses there. Okay, in order to call the parse, it's going to take a string or some other type, and tag is of type object, so it's just the way that we're going to have to work with that. Now that I know that the tip objects, 3 public properties have been generated, I will take the amount to tip text block dot text should equal tip.tip amount, and then the total text block dot text equals tip.total amount. Awesome. Okay, so we'll call that in a moment. In fact, whenever you, let's call it here, and whenever the text is changed in that topmost text box up here, this bill amount text box, whenever that is changed, we're going to perform the calculation. And I'm going to introduce a subtle bug here. I'll come back and fix this. I know something's going to happen here. Whenever well, I think we could probably run it. So let's try to run the app now and see what happens. We should have enough wired up where this will work, at least to some extent. There still will be a couple of annoyances here, however, and we'll fix those. All right, so I'm going to put my mouse cursor here. You can see that I will have to make changes. But if I were to type 50 and then click away from this, 18% of 50 does equal $9, and so the total bill would be $59. All right, now there's a couple of things I don't like about this. For example, I would prefer that whenever we move out of the bill amount, I'd like it to be formatted nicely with the $sign and with the .00 or whatever the case might be. Let's see what happens whenever we change the tip amount. It seems to reflect in the amount to tip and the total bill. Great. And that seems to work too. Great. So there's a few annoyances here that I'm going to need to work on. Like I want that part fixed right there. So let's go back here. And whenever we get focused, what I want to do is clear out the text box. So bill amount text box text equals that. That should fix that problem. And let's now run the app and see what happens. All right, so now whenever I go to type in something and I click away, that seems to work. Let's see, 68. All right, that seems to work as well. Great. Now let me go ahead and fix this too. Bill amount text box dot text equals tip dot bill amount. This should, since we've done all the hard work in our tip.cs to format bill amount, we should be able to reuse it here whenever the amount text box loses focus and to format it nicely. So let's see if that works. All right, so I'm going to type in 69 and then tap away. You can see that it reformats the bill amount appropriately. Great. And I think that's all that we're going to need to do to make this work. I had another thought to fix something, but it really hasn't seemed to pop up, so I'm just going to ignore that for now. But if it pops up in the future, essentially we may have to wait until we know that the grid, that the whole page is loaded before we attempt to perform the calculation. So it doesn't perform the calculation the first time, since we're calling it whenever the text changes or whenever the radio button has changed. But since I didn't see that to be a problem, I think by virtue of the fact that I implemented things a little bit different than I did the first time around when I was practicing this, it doesn't seem to be a problem. So there we go. That's the entire app. I'm not saying that it's ready for the App Store necessarily, but in a relatively short amount of time, we were able to completely build an app using many of the controls that we learned about a couple of lessons ago. And so we would then, at this point, want to go in and in the package.appxmanifest, we might want to change the visual assets and things of that nature. I'm going to do that in another app that we'll build together. I'm not going to do that here, but those are some of the final touches we want to put on this app before we attempted to upload it to the App Store for ingestion and inclusion in the App Store. Okay, so that wraps up this lesson. In the next lesson, we're going to rebuild this app, but we're going to build an app that will work for both the phone and for the Windows 8 store, so that we can allow our users to use it in both situations. And you'll see how easy this is with the universal project template. And we'll do that in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps to the world's best companies as quickly as possible. So we're going to take the work that we did in the previous lesson and we're going to translate it into a universal app, which will allow us to distribute our tip calculator to both the phone and to the Windows 8.1 App Store for inclusion there. And it's very easy to do. So to begin, we're going to make sure that under the templates on the left-hand side that we select Universal Apps and then select a blank app for Universal Apps template. And here we're going to call this tip calculator universal. Okay, so there are 3 projects, and you can see that the projects are all named the same with a dot, Windows Phone, tip calculator universal dot shared. So basically, the Windows and the Windows Phone projects should only be different in so much that they have similar but different XAML to lay out based on screen size or for their specific differences. And then anything that we can share should be added to this shared project. So in our case, this architecture really becomes easy. We're going to put our tip.cs class in the shared project and then reference it from both our Windows Phone project and the Windows project. And so to begin, let's start with our shared project. I'm going to right-click the shared project and select Add New Item, and we'll add a new tip.cs class. And I literally am going to go and copy and paste the work that I did previously here and paste it over the top of the tip class here. And so we have an exact duplicate, no changes required here. Great. So let's close that. And now that tip class will be available to both my Windows and Windows Phone projects. Let's begin with the Windows Phone project. Since we've already created that once, this should be just a matter of, let's change this down to 50%. Let's move this over a little bit. This should be just a matter of going to my main page XAML and copying out all the work that I had done previously, creating the 3 rows, creating the text blocks at the very top, and then the stack panel with all of my bill amount, tip amount, total bill, the radio buttons. Everything should be the same there. Now, obviously, I'm going to have to recreate some of these. So I'm just going to select each one and hit F12 to go ahead and create the stub for the event handlers. So you can't see me doing this, but I'm actually hitting F12 on my keyboard every time I find an event that I need to implement. I think that's all that I need to do there. Great. So then, in my code behind, I'm going to add that little helper method that I created to call the perform calculation, and that should be the same. In the radio button click, I want to call the perform calculation. Looks like my stack panel doesn't want to work correctly. Let's see what's wrong here. See if we can save it and see if that makes any changes to it. Oh, right. We want to do this too. At the very top, we want to create a private field called tip. We can just do a private tip. It'll be the same thing. And then we'll create a new instance of the tip class. See if that fixes anything. Well, it likes tip, but it doesn't like these other things. Here, let me try this real quick. I have a feeling I know what the problem is. Instead of name, let's try x:name. And a couple of these, let's see if that fixes the problem. It does. All right, in fact, all the problems are fixed. Maybe IntelliSense probably just needed a moment to catch up with me. That's all. Sometimes I freak out a little bit when I see the red squigglies, and all I really need to do is just wait for a moment. But if that does pose a problem for you, try adding the x: in front of the word name, in front of the attribute name, and that should fix it. Okay. So whenever we lose focus, and again, I'm just copying over from the previous project and pasting in some of this work that we've already done. Text changed. We can put that there. We want to zero out whenever we get focus, clear out the existing values there, and I think that's all that we really need to do. So now let's right-click this project name in the Solution Explorer and set this to the see if you can see this. Set as startup project popped off the screen there, but you want to select set as startup project in order to make this, as you can see, it's now highlighted or bolded inside of the Solution Explorer. And let's run it in the emulator and see what happens. Alright, so let's type in, let's say it's a $75 bill, and I'm going to tip 25%. And that looks like it all works, so I'm pretty happy about that. Now, let's go ahead and create the Windows version of this. I'm going to right-click and select Set as Startup Back, so that now we're going to work with the Windows emulator. And I'm going to close these down because it can become awfully confusing. And close that as well and open this. And then go to mainpage.xaml. And you can see we get more of the surface view. All right, let's pull this down to 50%. And even though this is not a series on building apps for the Windows App Store, Universal Apps will allow us to reuse most of our code that we're building for phone apps, and it's just going to be a huge boon to both app stores and to your development efforts. I mean, isn't it great that you're going to be able to sell now your apps for 2 platforms instead of just one? A platform, by the way, that has, you know, tens if not hundreds of millions of installed users. Sounds good to me. Okay, so what we're going to do, and this is where things get remarkable as far as I'm concerned, I'm literally going to go back to the well, back to the work that we did to build our phone's UI, and I'm going to paste the definition of the rows and the stack panel and everything just right in there. And when I do that, notice that it lays out pretty stinking good. I mean, yeah, we've got a lot of blank space here that we're not using, and I could rework a lot of this to make it utilize some of that blank space. But you know what? As a first pass, this is pretty good. I'm pretty happy with this. It's the promise and the value of XAML that I'm able to just reuse it in both these contexts, and it works well. Of course, the proof is going to be in the code behind. So let's go ahead and go through that same procedure that we did earlier. I'm going to put my mouse cursor on each of the event handler names and then hit the F12 key on the keyboard to go ahead and add those stubbed out event handler methods, like so. Great. And then what I want to do is, I know I'm going to need almost the identical code. For example, I'm going to need this helper method called perform calculation. I'm going to need to create a new instance of tip. So at the very top, we'll go private tip, and then here I'll go in the constructor tip equals new tip, like so. And then in the radio button, I'm just going to call perform calculation. I'll also call that from the text changed event. Whenever we lose focus, I'm going to retrieve the value from the tip object for the bill amount so that it formats it nicely. And then finally, whenever I put my mouse cursor inside of the amount text box, I want it to clear out the existing value. All right, so let's go ahead and let's run it in the simulator. So I just drop down the little arrow next to the run button, and instead of running it full screen, I'm just going to run it in the simulator, and hopefully that'll be small enough so that you can see it on camera here. If not, then you might miss some things. So here, I'm going to pull this down. Looks beautiful. Look at that. How great that is. So let's type in like $46, and I'll set the value to 25%, and that looks great. Unfortunately, we pushed out of it for some reason, but it seemed to work just fine. And that, my friend, is how you create a universal app, one code base, almost identical XAML layout. I could tweak that if I wanted to make it look good on that larger form factor, but I didn't do anything, and it looked just fine, at least for this initial version. So now you can go forward and prosper doubly. Whatever you're going to build it for both apps. Build it with that in mind. Keep everything that is going to be the same between both apps. Try to keep it in that same shared project, and then do as much of your work as you can in that shared project, and then just reference methods and so forth that are inside of that in the classes of your shared project from both the Windows and the Windows Phone projects. All right, that's all we need to do in this lesson. We've got 2 working apps that do the same thing. Outstanding. So we're going to pick this back up in the next lesson and continue pushing on so that we can build even more interesting and complex apps. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So we've seen the Windows Phone emulator at work already in this series so far. It's a crucial component to developing apps for the Windows Phone platform. So I wanted to spend a little time to become more familiar with the functionality of the emulator and maybe point you in the right direction for some additional information about it. So in this lesson, we're going to learn about the phone emulator, what it really is, and how it supplies different versions for different deployment scenarios. We're going to learn about the function of the emulator, including keyboard shortcuts that you can use that will simulate depressing the various physical buttons on a physical device, such as on the face and on the side here. And then we're also going to talk about this little toolbar here that floats off to the right hand side that will allow us to resize and rotate the emulator, and how to handle the virtual machine as if it were a physical device. So how to get accelerometer support, GPS support, and the like, only using this virtual machine, the phone emulator. So what exactly is the Windows Phone emulator? Well, in a nutshell, it's just a desktop application that simulates a Windows device, and it actually has similar performance to what you would expect on a physical device. It provides a virtualized environment in which you can debug and test your apps without having to have a phone in hand. In fact, the emulator is running Microsoft's Hyper-V, which is their virtualization software. So if you're familiar with that, that should mean something to you. So up to now, whenever we clicked the Run button to start debugging our applications that we've been building, we've just accepted the default emulator, which is this Emulator 8.1 WVGA 4-inch 512 megabyte default. But if we were to drop down the list, you can see that there's many other options as well, including one to actually deploy to a device. So if we had it hooked up, and if the phone was running the 8.1 operating system, then we could debug our apps on the phone itself. Unfortunately, as I'm recording this video, it's a little early for that, not ready for that, so I can't demonstrate that feature. However, what we can take a look at are some of the different form factors, screen sizes, and things of that nature. Now, as we look through this list, you can see that there's a number of different resolutions. This WVGA 720p and this 1080p. And what is this? Let's start with this 512. What does this really mean? Well, it indicates that we're running in a memory constrained environment. So the default emulator image that we're running here right now, this virtual machine image that's running, is it's emulating a memory-constrained Windows Phone 8.1 phone. So, for example, the Lumia 610 is an inexpensive entry-level phone that can run Windows Phone 8.1. It only has 256 megs of RAM, and by contrast, the phone that I have in hand here, the Lumia 920, has a gig of RAM, and some of the newer phones even have more than that. So on the lower RAM devices, having multiple apps running at the same time or creating a memory-intensive app could cause performance problems. So to be sure that your app will run well on those types of lower end devices, lower RAM devices, you can test your app using a realistic emulator image. So, and there's a number of great articles about RAM usage on MSDN. Let me point you out to just a couple that I found. Admittedly, these are articles for Windows Phone 8, but the concepts are still true in Windows Phone 8.1. So here's the first one, is this app performance consideration for Windows Phone 8, and then this blog post, optimizing apps for lower cost devices. You should take these into consideration before launching your and trying to sell your app on the App Store. So back to our discussion of the default image that's being used here, this Emulator 8.1 WVGA. We looked at the 512 megabit. What does this WVGA stand for? Well, the emulator allows you to test your app on a unique emulator image for each of the screen resolutions that are supported by Windows Phone. This default selection encourages you to target the largest possible market for your Windows Phone 8.1 app. And so there are several resolutions that are available. WVGA is the one that we're working with, and that supports an 800 by 480 screen resolution. However, there's also this WXGA, which is could be essentially the same screen size but a higher resolution of 1280 by 768. And then there's the 720p, which is 1280 by 720, and then finally the 1080p, which is 1920 by 1080. So if you run the default like we've done here, and we go back out to the settings, so let's go all the way down, and if you go to the About, which should be near the bottom, yeah, here we go, you can see that this is confirmed whenever you hit the More Info button. You can see here that we have a resolution of 480 by 800. Okay. So how does that translate into actual phones on the market? How do these options that we see here, the various screen sizes, WVGA, XGA, 720, and 1080p? Well, the Lumia 1520 seems to be the largest of the phones currently available. There were some announcements made during build of some newer phones that are coming onto the market, but the 1520 is 6 inches, has a 6-inch screen, and it is a full 1080p, the 1920 by 1080. The Lumia Icon, another popular model, is only 5 inches, but it still has the full 1080p. The Lumia 1020, and then this is the Lumia 920, it has the WXGA support, so 1280 by 768. And then, like I said a little bit earlier, the Lumia 610 is only a 3.7-inch screen, and it supports the WVGA, which is 800 by 480. So yeah, and I realize that by the time you watch this, there will probably be newer phone models available, but the point is that you should be aware of the fact that you'll need to support different screen resolutions and memory constraints, and the emulator will help you try out your app in the various different screen resolutions just to see how things are laid out, and perhaps some ways in which you could improve the layout for a given screen size. So I'm not going to spend a lot of time talking about the basic functionality of the emulator itself. If you're familiar with the Windows Phone, you should know how to find your way around between the start screen and all the apps that are available, and how you can, jump to a certain grouping of apps based on their the letter in their name, and how to work with, for example, the settings and change not only things like the themes and things of that nature, but other features. And many of these in the emulator are not completely implemented because, again, we're not dealing with a physical device, we're dealing with a software emulation of the device. And furthermore, many of the apps too, like for example Bing Finance, at least on this particular version of the emulator, a pre-beta, I guess you could say, or a release candidate, it doesn't have those sorts of things supported. However, having said all of that, it's almost identical to the experience you would have with the physical phone in every way, in terms of the look and the feel, how to navigate around, and things of that nature. And so you even have at the very bottom the same buttons that you would have on the physical phone, with go back, start, the Windows Start button, and then also the search button. Okay, and there's also, for example, my Lumia has 3 buttons here on the side for volume and for power and for taking a picture, and those are represented, as you can see, barely on the side here of the emulator as well. And there's a list of keyboard mappings here at this web page, how to use the computer keyboard with the emulator for Windows Phone 8. These apply to Windows Phone 8.1 as well. And so, for example, it might be more convenient, since it's difficult to press these buttons on the side here for power and for volume up, volume down, to actually use their equivalent with the function keys on your keyboard. All right. Additionally, you can see that you have some options like pushing down the camera button halfway versus full, and so on. Additionally, ones that are most pertinent to me, like for example, if we were to go to Internet Explorer here, and let's just go recommended, and I put my mouse cursor inside of the location bar, I can use the page up and the page down buttons to remove or to show the keyboard. Okay, and so for example, I can just use, if I go page up, there we go, www, or how about this, channel9.msdn.com. all right, and so you can see that currently build is going on right now, but at any rate, it's mostly a full functioning version of Internet Explorer, and some of the other apps are fully functioning as well. Okay, so let's move our attention now to this floating toolbar off to the right hand side. Obviously we can minimize, we can close down the entire emulator. I would encourage you not to do that. You don't need to shut down the emulator every time you stop debugging. So as you can see, the very first time that I run my app for a given programming session, it will bring up the emulator, and when I stop debugging, the emulator will still stay on my screen. It's great. You should do that. Leave it running, because it takes a little longer to boot it up, since you're essentially rebooting the whole operating system every time. And so the arrow key allows me to use like a single finger, whereas I can use this other option to do the pinching, or the other motion, the reverse pinch, which will allow me to zoom in and zoom out. So I want to move the single point input as opposed to multi-touch input. I can change the rotation of the device and see how my app responds to rotation if I've built in the correct layout to accommodate that. I can turn it, keep rotating it in various directions. I can fit the emulator to as large as it will go for my screen, or I can choose to use the zoom and set the zoom level down a little bit lower, to 50% in this particular case. Right now the help button doesn't really work. Again, I suspect that's the version of this emulator that I'm currently working with. I think that it's just a matter of not being ready just yet. However, what is interesting is the double chevron icon, which opens up this tools menu, and we're going to spend a little time talking about this. On the tools, additional tools dialog, there are 8 tabs, and so we'll just go through each one by one. You can take, for example, this little orange point, and you can move the phone around, and if your app supports this type of accelerometer support, then you'll see different things appear here in on the page, because we're basically laying it flat on a table versus picking it up and holding it straight up. You can see that there are some presets here, like portrait flat, portrait standing, and things of that nature. We can reset it, and then also recorded data, for example, the shake. Now you won't see anything on screen except for the X, Y, and Z going crazy, and that's because it simulates somebody taking the phone and shaking it around. All right. Next up is location, and this will help you test the GPS support in the phone. So for example, if I were to search for Chicago, Illinois, where I grew up, and I can then zoom in a little bit to find the exact neighborhood where I grew up. I can right click to set a pin, or I'm sorry, I can actually left click to select and set a pin, and that will show the exact latitude and longitude for that pin drop there, point number 1, and I can set additional ones as well. And Also here in the accuracy profile, I can introduce variance to the accuracy. In some areas, there are fewer ways to determine the exact location because there are fewer physical resources like cell phone towers and so on that are typically used to help triangulate the location of the phone. So the accuracy profile allows you to adjust this to test your app and how it performs in less accurate scenarios. So for example, if you're in a rural setting, you would expect the accuracy to be less. I'm not sure that it's completely working right now, but or maybe it can be edited somehow, but they all seem to be functioning with exact numbers. So I'm just going to move on from there and go to the screenshot. So I can take a capture of whatever's inside of the phone that's currently displayed inside the main window, and I can use that for debugging purposes. I can copy this, save it off to my hard drive, and then send it off as a bug report or whatever the case might be. The network tab just shows you the network adapter and the IP address and things of that nature. So that might be helpful if you're developing an application that's network aware. Additionally, there's this enable network simulation to throttle the bandwidth of the phone. So let's say, for example, your app needs to, you want to test it to see what would happen if there is no network currently. Will the app crash? Will it hang? Can I deliver a better error message or user experience? Or what if the data is coming down with 2G and it's very slow? Or what if it's a little bit faster and maybe I can change it to poor signal strength with a very slow connection? So that allows us to enable various network scenarios. Very cool. Here is the SD card. We can designate a specific folder on our hard drive to simulate an SD card that's removable. So if we want to print data to the SD card, we can then go into that particular folder on our hard drive where we're developing our app and see exactly what was written and so on, because that will simulate what will be written then to any SD cards that are inside of the physical phone. Notifications, this is for simulating push notifications. We're not going to talk about that in this series at all. There are checkpoints. So if you think in terms of, if you're familiar with virtual machines, you are able to save essentially the current state of this virtual machine, of the emulator as it is right now, as a checkpoint. So this allows you to test a scenario where the phone is configured in a certain way, and you can just keep testing that scenario over and over and over by restoring the specific checkpoint that you made at a given point in time. So think again of virtual machine snapshots, because that's really what's happening here behind the scenes. And then finally, you can select which sensors that you want to enable on this virtual emulator, and what happens if a given device does not have support for those sensors. You can turn off NFC and the gyroscope if your app is expecting those to work, and you can see what the experience will be for the users who don't have those enabled. All right, so that pretty much wraps up all the emulator itself, and there are some areas where we could go into more depth, but they're really specialized depending on which features you're trying to enable inside of your app. There is something that I pointed out previously. Let's see if I can find it here. I think what you have to do is actually open up a XAML page, and then yes, it appears here. So there's this device option. We talked about this to some extent. It's not quite the same thing as the emulator, but it's similar in so much that it's a tool that helps you during development time. So let's reduce down the size of our designer, and then open up, actually move it over here a little bit more, and move it there, and then open up the device. And we can change, for example, the accent, whether we want it to be a dark theme or a light theme, whether we want to show the chrome around the window in the designer surface, whether we should show the status bar at the very top with cell phone signal and battery and things of that nature. And we can also choose like the orientation, so we can try different layouts during while we're developing. And then finally we can choose different scales, 9:15, 9:16, different resolutions, whether we want to use WVGA, XGA, 720p or 1080p. And this will make our screen very large. Obviously, let's go ahead and reduce this down even more to like 20%. So we can see that we have even more space to lay out controls and maybe stack things a little bit differently based on what we see at the different display options that we have. So let's go ahead and set that back. All right. So as you see, there are many ways to test and monitor your app during development time and debug time, so you can gain some confidence in how it'll perform when you distribute it to the store. One note, Microsoft does recommend, though, that you do deploy your app to a physical device and test it before you submit it to the store, and I would encourage you to do that as well, to see really how it performs on a real device, not just trust the emulation software. All right, so to recap, the emulator is a great tool that allows you to quickly deploy your app during development to a virtualized Windows Phone. We looked at how to test different device sizes and memory constraints and how to manipulate the emulator to test for rotation and motion and how to make the phone think that it's geographically located in Chicago as opposed to Dallas, as opposed to Seattle. All right, and we're going to use these skills throughout this series as we add various features to the apps that we build. So that's all I have to say about the emulator. Hopefully that was helpful, and we'll pick it back up in the next lesson. We'll see you there. Thank you.